Today we're going to be doing lesson 5.3. It is on page 277 of our book. We're going to be solving compound inequalities. So a compound inequality is two or more inequalities that are connected by the words and or. So compound inequality containing the word and is only true when both of the inequalities are true. So its graph is where the graphs of the inequalities overlap. This overlapping section, we call it an intersection. So here's a quick example. If we had this and this, only this part would be true because that is where they overlap. And that's where we're going to start with example 1 and show us a compound inequality using the word and. So here is how many of them are set up. We have the variable in the middle. In order to solve this, we need to break this apart into two different inequalities. So we're going to take the first one, we're going to rewrite it as -8 is less than or equal to h. And then, -2, I forgot that part. So everything between the two inequality symbols gets used twice. So this time, we're going to write this one. We have h minus 2 is less than or equal to 1. These put together create this. Now we're going to solve. We need to get h by itself. So over here I'm going to add 2. Add 2. -8 plus 2 is -6 is less than or equal to h. Now we have to do the other one. Add 2. Add 2. H is less than or equal to 3. Now when we go, we're going to put this together into a solution set, and we're going to write it in set builder notation. So we're going to go our bracket. We're going to tell us what variable we've been working with, and then we're going to create the answer. When we create the answer, we're going to put these back together. How normally when we write this, we bring the variable first. When it is a compound inequality, the variable should be in the middle. So I'm going to go -6 is less than or equal to h, and h is less than or equal to 3. And I'm going to end my bracket. So as you see, it is this one smushed together to make 1. And then we're going to go and we're going to graph this on our number line. So here we have our answer. I'm going to put a closed circle on -6. Because it has the is equal to. I'm going to put an open circle on 3. And h is between these two numbers. So I would draw my line between these two circles. My line is terrible, but I was trying to make sure that you could see it. And this would be the answer, the solution. If you have not watched this yet in class, done this with me in class, I want you to pause the video and do the check. If you have done this in class, I'm going to go ahead and go over the check. So I'm going to start by writing the problem. -7 is less than or equal to 3x plus 2, which is less than or equal to 5. If you notice, back up here, it's going to go smallest number, variable in the middle, larger number. So going here, I'm going to separate it into 2. I'm going to take the first part, I'm going to separate it. -7 is less than or equal to 3x plus 2. And then I'm going to separate it again. 3x plus 2 is less than or equal to 5. And now I solve both inequalities. I'm going to subtract 2. Subtract 2. Now I have -9 is less than or equal to 3x. Divide by 3. Divide by 3. -9 divided by 3 is going to be -3 is less than or equal to x. Now I do this side. Same thing. -2. -2. 3x is less than or equal to 3 divided by 3 divided by 3 x is less than or equal to 1. Remember, we need to merge these back together in order to create our solution set. So I have x as a variable. I have negative 3 is less than or equal to x, but x is also less than or equal to 1. And then we need to go back and graph it. See both? Here's my answer. Here's the graph I'm graphing on. So negative 3 has an is equal to sign, so negative 3 is going to get a closed circle. Negative 3 is between negative 2 and negative 4. 1 has an is equal to sign, so 1 is also going to get a closed circle. And our answer lies between, x lies between these 2 points. Moving on, we're going to go to example 2. A cereal manufacturer distributes cases of cereal to grocery stores. Each case contains 12 boxes of cereal. In order to pass the manufacturer's quality assurance test, the case must weigh between between 336.4 ounces and 331.6 ounces, which includes 34 ounces for the weight of the case's cardboard box. So, you know how I like to do this. I'm going to cover this up. We're going to work on how to find the inequality without just letting the book do it for us. So I can see here that the case must weigh between 336.4 and 331.6. Okay, if you remember back from example 1, I said we needed to go from smaller to larger. So I'm going to start here with my 331.6. And eventually I know I'm going to get to this 336.4. So this is going to be as small as it gets, so everything must be larger than it. And this is going to be as large as it gets, so we're going to go there. It also says that we're going to have 12 boxes of cereal. Okay, 12 boxes of cereal in order to pass the test. And it says it includes, oh, I forgot my B, 12B, 12 boxes per case. And the case, where is it? It includes the 34 ounces for the weight of the case's cardboard box. So I have to include the 34 ounces per cardboard box. Okay, so the question it's asking, we need to solve the inequality to describe the weight of a single box of cereal. Okay, so we're going to do what we learned in example 1, and we're going to separate these out. So I have 331.6 is less than 12B plus 34. I'm also going to have 12B plus 34 is less than 336.4. We're going to solve these two inequalities. I'm going to, over here, subtract 34 because I'm trying to get the variable term by itself. So minus 34. When I subtract 34 from 331.6, I'm going to get 297.6, and this is less than 12B. My next step is to get 12B, to get the B part by itself, so I'm going to divide by 12 because this is multiplication. Divide by 12. I now have 297.6 divided by 12 is 24.8 is less than B. So the least amount that the box of cereal would weigh is 24.8 ounces. Now I must come to my high end. I'm going to start by subtracting 34 to get the variable term by itself, minus 34. So I have 12B is less than, this is going to be 302.4. Need to get the B by itself, so I'll divide by 12. Divide by 12. B is going to be less than 302.4 divided by 12 is 25.2. So the least amount the box of cereal could weigh is this. the most amount the box of cereal could weigh is this, but it's between. Remember, it did not say at least or at most or anything like that, so it is between these numbers. It cannot actually be this. This is going to be an open circle. This is not one of the answers. This cannot be this. This is not an open circle. This cannot be one of the answers. The answers lies between these two. Let's first write it in a solution set. So I've got B, 24.8 is less than B, and B is less than 25.2. And then I need to graph it on my graph. So I'm going to go 24.8 is going to have an open circle. So 24, 2, 4, 6, 8, 10. So I'm going to have an open circle here. And then 25.2 is also going to have an open circle. So 25.2 is going to have an open circle. And then my line lies between them. You're going to try the check if you have not already. Okay, because Sean has been saving to buy his first car. He wants the total cost of the car and fees to be more than $5,000, but at most $7,000. The fees for buying a used car, such as title, registration, and dealership fee, will be $700. So we have to set this up. He wants the total cost of the car to be more than $5,000. So we're going to go 5,000, and it should be more than that. It didn't even say a minimum of 5,000. It said it should be more than that. But then it does say at most 7,000. When it says at most, we can add the is equal to symbol. It told us the fees for buying a used car were $700. So I'm going to add 700 to, I have no idea how much it's going to cost, so I'm going to use an X. So now I'm going to solve. I'm going to separate. I've got 5,000 is less than X plus 700, and X plus 700 is less than or equal to 7,000. Here I'm going to subtract 700, subtract 700. So now I have 4,300 is less than X. And now I go over here. Subtract 700, subtract 700. X is less than or equal to 6,300. I'm going to mesh them back together. So set builder notation. 4300 less than X, which is less than or equal to 6,300. And then we have to graph it. I'm going to go back here. 4,300 is going to lie between 4,500 and 4,000, and it is going to be an open circle. 6,300 is going to lie between 6,000 and 6,500. It is going to be a closed circle, and the cost of his car is going to lie somewhere between these 2 points, with 6,300 being a possible answer. Moving on to the end of this video, we're going to work on example 3. Example 3 is where we are going to use the word or. Compound inequality containing the word or is true if at least one of the inequalities is true. The union is the graph of the compound inequality containing or. So if we had this inequality or this inequality, we would put it together and make the graph look like this. So we're going on to example 3, switching back to my notes so we have room to write. So with the word or, it is separated for you already, and you just have to solve. So here I'm going to subtract 8, subtract 8. I have 4n is less than or equal to 16 minus 8 is 8. Going to divide by 4. Divide by 4. N is less than or equal to 2. Or, now I do this side. Going to subtract 7, negative 3n is less than negative 18, and I'm going to divide by negative 3. Divide by negative 3. I have n. I divided by a negative, so I have to flip my sign. And negative 18 divided by negative 3 is going to be positive 6. So I have an or here. Let me show you how we graph this. Sorry, I'm trying to make it to where you can see the answers while I write it. So here I have n is less than 2. Less than or equal to 2. So on 2, I'm going to have a closed circle, and n is less than, so the line is going to be this direction. Or n is greater than 6. This is going to be an open circle on 6, and n is greater than, so we're going to go this direction. And our graph is going to look like that. When we write this one in set builder notation, we're literally going to use the word or. So we're going to go bracket n is less than or equal to 2, or n is greater than 6, end bracket. And that's how we do example 3 with or. There is a check if you turn the page to page 280. You're going to try the check at the top. Just writing it down. 5x plus 1 is less than 11, or negative 3x plus 10 is less than or equal to negative 11. So here I have the problem written down, and we're going to solve both inequalities. Minus 1, 5x is less than 11 minus 1 is 10. Divide by 5, divide by 5, x is less than 2. Or this side. I'm going to subtract 10. Subtract 10. I have negative 3x is less than or equal to negative 21. I'm going to divide by negative 3. Divide by negative 3. X, my sign flips, is greater than negative 21 divided by 3 is positive, by negative 3 is positive 7. Go ahead and write it as set builder notation so we don't forget. X is less than 2, or x is greater than or equal to 7. Then we're going to go ahead and find that answer. X is less than 2, or x is greater than or equal to 7. So my answer is A. And then I need to graph the solution set. So x is less than 2. So here's 2. That's going to be an open circle. And we're going to go x is less than, so we're going this direction. And then x is greater than or equal to 7. So that's going to be a closed circle on 7. And x is greater than, so we're going to go this direction. And for this video, I'm stopping at example 3. See the next video for example 4, 5, 6.